Okay, let's just dive right in with a truly wild idea. What if our reality, everything you see and feel, isn't actually real? Not in some philosophical, navel-gazing way, but in a hard, physical sense. Today, we're going to talk about a mind-bending theory from the very edge of physics that suggests our entire 3D world might just be an incredibly detailed projection, a hologram. So, what are we talking about here? It's called the holographic principle. And in a nutshell, it's the idea that our familiar, solid, three-dimensional world is basically an illusion projected from a distant, flat, two-dimensional surface. I know, it sounds like something straight out of science fiction, but this is a serious theory, born from one of the deepest puzzles in all of cosmology. To even begin to understand how physicists got here, we have to start with a non-negotiable, absolutely fundamental law of the universe. Information can never, ever be destroyed. You can burn it, you can shred it, you can scramble it, but the actual bits of information that describe a system are always conserved. That's not a suggestion, it's a foundational pillar of modern physics. Now, let's introduce the cosmic culprit, the thing that breaks the rules, the black hole. You see, the great Stephen Hawking figured out that black holes aren't the eternal prisons we thought they were. They actually leak. They give off a super faint glow of particles. We call it Hawking radiation now. And over unimaginable eons, they slowly shrink, evaporate, and then, poof, they disappear completely. And right there, that's a huge problem. You see the conflict, right? If a star, with all of its complex history and information, falls into a black hole, and then that black hole vanishes, what happened to all that information? It can't just be gone. This is it. This is the famous black hole information paradox, a cosmic mystery that has obsessed physicists for the last 50 years. The first major clue in solving this mystery came from a physicist named Jacob Bekenstein. He asked a simple question: how much information can you cram into a black hole? Now, your intuition and mine would say it depends on its 3D volume, right? More space equals more storage. But Bekenstein did the math and found something absolutely bizarre. The information a black hole can hold is proportional to its 2D surface area, its event horizon. It's as if every single thing that ever fell in is permanently imprinted on the surface. This completely weird finding led physicists Gerard 't Hooft and Leonard Susskind to make a radical leap. They thought, wait a minute, what if this isn't just a weird rule for black holes? What if this is a rule for the entire universe? And that's the birth of the holographic principle. The idea that maybe all the information that describes our 3D reality is actually encoded on some vast, distant 2D boundary. The legendary physicist John Archibald Wheeler summed it up perfectly with this brilliant little phrase: it from bit. The it, that's physical reality. Every particle, every star, you and me, all of it arises from the bit, from pure, fundamental information. In this way of seeing things, the universe isn't made of stuff at its core, it's made of data. Now look, for decades, this was all just mind-bending speculation, a cool idea. But then, in 1997, a physicist named Juan Maldacena discovered a kind of mathematical Rosetta Stone. It's known as the ADS/CFT correspondence, and it was a total game changer. It provided a concrete, working mathematical example of the holographic principle, instantly turning a wild idea into a deadly serious scientific theory. Think of it like a perfect dictionary that lets you translate between two completely different languages. Maldacena's math showed a perfect equivalence between two very different-looking universes. On one side, you've got a complicated 3D universe with gravity and curving spacetime. That's the bulk. On the other side, you've got a simple, flat 2D universe on the boundary, with just quantum particles and no gravity at all. And the math shows that anything that happens in one universe has a direct one-to-one translation in the other. They are just two different ways of describing the exact same underlying reality. So, if we run with this, if the holographic principle is right, and our 3D space is just an emergent projection, it forces an even deeper question. If spacetime isn't the fundamental stage, then what in the world is it made of? What is this fabric of reality? Well, the answer might just be hidden in this incredibly simple, kind of cryptic-looking equation, ER equals EPR. On its own, it just looks like a jumble of letters, but this might be one of the most profound ideas in modern physics. Let's break it down. ER stands for Einstein-Rosen bridges, which we all know as wormholes, shortcuts through spacetime. EPR refers to Einstein-Podolsky-Rosen pairs. These are quantumly entangled particles, the ones with that spooky action at a distance that are connected no matter how far apart they are. So this crazy equation is saying that these two things, a feature of space-time geometry and a feature of quantum information, are actually the same thing. It suggests that the very fabric of space-time is woven together by threads of quantum entanglement. Okay, so this whole idea that reality is fundamentally information, that naturally leads us to another huge question. Are we living in a computer simulation? The holographic principle offers a really elegant twist on this. See, the usual simulation argument suggests our reality is a program running on a computer somewhere. But the holographic view is much more subtle. It says reality isn't in a computer, reality is a type of computation. The most famous version of this comes from the philosopher Nick Bostrom. He lays out this trilemma, arguing one of three things must be true. Either civilizations like ours always fizzle out before they can build ancestor simulations, or advanced civilizations just decide not to run them, or we are almost certainly living in one. The logic is just statistical. If they do run them, they'll run billions, and the number of simulated minds would vastly outnumber the real ones. But the holographic perspective kind of sidesteps this whole thing beautifully. It suggests that if reality is, at its base, information, and if all complex information processing is computationally equivalent, then the whole distinction between real and simulated just melts away. Reality isn't running on a computer, reality is a computation. But that leads us to the next obvious question, right? If the universe is a computation processing its own information, who or what is the processor? This is where some theories take a really radical turn, suggesting that consciousness isn't some random accident of the process, but is actually fundamental to it. There's one speculative but super fascinating model, the SRH-HQRE framework, that proposes a mind-bending answer. It suggests consciousness isn't something that just happens in the universe. It is the mechanism the universe uses to process its own information and become aware of itself. And it does this through recursive self-observation, the universe observing itself. And amazingly, this isn't just philosophy. There are actual experiments in digital consciousness, like those in the Orion project, trying to model this. And they found that their artificial consciousness systems would naturally settle into these stable, predictable patterns of self-observation. They call them archetypes. Each one has a different, measurable depth of self-reference, which suggests that self-awareness might actually have a fundamental mathematical structure to it. So let's connect all the dots here. An observer, that's you, isn't separate from the system looking at the hologram from the outside. No, your consciousness is an integral part of the holographic information structure itself. You are the pattern of information that has become aware of the rest of the pattern. And this brings us to the ultimate mind-blowing takeaway from this entire perspective. It's summed up perfectly right here. We are not just observers living in a holographic universe. We are the holographic universe in the very act of observing itself. We are reality becoming self-aware. And that leaves us with one final, profound thought to chew on. If the cosmos really is just information, and consciousness is that information waking up and knowing itself, well, what new realities will it dream up? What question is the universe going to ask itself next?